Hello everyone, welcome to Druv Online Academy. In this video, we can revise hypothesis testing. It's a huge topic. In this video, we can see an overview of it and we'll have an idea of what is hypothesis testing and what are the steps involved in it. Hypothesis is an assumption statement. It proposes a tentative explanation about the variables involved. This hypothesis will be tested later on and it can be accepted or rejected. So the hypothesis should be testable and verifiable. It needs to be clear and specific. Only such a hypothesis will help the researcher to stay on the right track and focus only on the variables that matter. Now we can see the steps in testing hypothesis. So testing hypothesis starts with specifying the null hypothesis and alternative hypothesis. Then we need to set a level of significance and choose an appropriate statistical test to analyze the data. Then we need to calculate the value and draw a conclusion whether to reject or accept the null hypothesis. Null hypothesis suggests that there is no statistical significance between the variables involved in hypothesis. So null hypothesis will state that there is no significant difference between the groups involved or there is no significant relationship between the variables involved. On the contrary, alternative hypothesis suggests that there is a statistical significance between the variables in the hypothesis. So alternative hypothesis will say that there is a significant difference between groups considered for the research. There is a significant relationship between variables involved. We'll see an example. For example, if we are going to study gender and IQ levels, null hypothesis would state that there is no significant difference between men and women in their IQ levels. But alternative hypothesis will suggest that there is a significant difference between men and women in their IQ levels. Directional hypothesis. This is an alternative hypothesis which predicts that results of one particular condition will be greater than the other. That is, one group will be greater than or lesser than the another one. This is directional hypothesis. And one-tailed test is a statistical test of this directional hypothesis. This can be left-tailed or right-tailed. Next is non-directional hypothesis. Two-tailed test is a statistical test of non-directional hypothesis. This does not mention the direction of the change. It only just states that there is a significant difference. It does not suggest if it is greater or lower, if it is higher or lesser. It only says that there is a significant difference. Here, the first one is null hypothesis, which says M1 is equal to M2. That is, mean of group 1 is equal to mean of group 2. There is no difference between group 1 and 2. There is no statistical significance. Whereas 2, 3, 4 are alternative hypothesis. If you look at 2, H1 alternative hypothesis, it says M1 is not equal to M2. There is a significant difference between Group 1 and Group 2. This is a non-directional hypothesis. It does not specify which one is greater or lesser. But 3 and 4 are directional hypothesis because it suggests that one group is better over the other. Third one suggests that M1 is greater than M2. First group is better than second group. Fourth hypothesis that says that Group 2 is better than Group 1. Now we'll see what is right-tailed test and what is left-tailed test. If the critical region lies towards the extreme right of the distribution, the shaded area is the critical region. If this lies towards the extreme right of the distribution, then it's a right-tailed test. And if it lies towards the extreme left of the distribution, then it's a left-tailed test. Okay, now what is critical region? Critical region, here this is also known as the rejection region because if the calculated test statistic falls under this area, then the null hypothesis will be rejected and the alternate hypothesis will be accepted. So this is the rejection region and the rest of the curve is acceptance region. Two-tailed test is a test of non-directional hypothesis. Non-directional hypothesis only predicts that two groups will differ from each other. We do not know which one will be higher, which one will be lesser. It does not indicate the direction. As you can see here, the critical region lies in both the sides, both in left and right for a two-tailed test. Next is level of significance. Level of significance is set before testing the hypothesis. It is denoted by the symbol alpha. The level of significance is the probability of making a wrong decision when the null hypothesis is true. That is, rejecting the null hypothesis when it is true, which is also a type of error. We will cover that later. If the null hypothesis is true, we will accept it, right? But if we reject it, then it is an error. This level of significance indicates what is the probability of committing that error. Next step is to choose a statistical technique and calculate the test statistic. Now we can see some of the parametric and non-parametric tests used to test a hypothesis. First, t-test. This can be used to compare the means of two groups. T-test is used when the sample size is small and the variance is not known. If the variance is known and the sample size is large, then z-test can be used. F-test is used to test if two populations' variances are equal. It compares the ratio of two variances. ANOVA, analysis of variance. This is used to test if there is a significant difference between means of three or more independent groups. Chi-square test is a non-parametric test. So this is used for categorical variables. This test is used when the data available is in form of frequencies. Here, the fit between observed and expected frequencies is determined. Now, how do we make a decision regarding accepting or rejecting the null hypothesis? If the calculated value is greater than the table value, then the null hypothesis is rejected, and it implies that there is a significant difference. There is a statistical significance. Second, in what case will we accept the null hypothesis? If the calculated value is lesser than the table value, then the null hypothesis is accepted. This implies that there is no statistical significance. Here you can see the table of critical values of z statistic. Here level of significance are given, and for one-tailed and two-tailed tests. For a two-tailed test, for an example, at 0.05 level of significance, 1.96 is the table value. 1.96. Now, if the calculated value is more than that, say 2.12, in that case, the null hypothesis will be rejected because the calculated value is more than the table value, is greater than the table value. After calculating the test statistic, the corresponding p-value is also seen. What is p-value? P-value is a probability value. This is a number which describes how likely it is that the observed results, whatever results we have calculated, whatever results we have observed, would have occurred randomly by chance, without being real and without being statistically significant. That is, assuming the null hypothesis is true. So, smaller the p-value, stronger is the evidence for statistical significance. So, the null hypothesis has to be rejected. In the first case, if you see, p-value is lesser than 0.05. So, if this is the case, then the null hypothesis can be rejected. In the second case, if you see, p-value is greater than 0.05. If this is the case, then there is not so much of evidence to reject the null hypothesis. Now, we will see what is type 1 and type 2 error. When the null hypothesis is true, we are supposed to accept it. But in case if we reject it, that is type 1 error. Null hypothesis is false and we reject that is correct decision. Null hypothesis is true and it is not rejected. Yes, when the null hypothesis is true, we need to accept it. So that is correct decision. Okay. But when the null hypothesis is false, and we are not rejecting that. When it is false, it is supposed to be rejected. If we do not reject a false null hypothesis, then that is type 2 error. Now, we will revise some previous year questions. First question, In a research on the effect of child rearing practices on stress proneness of children in completing school projects, the hypothesis formulated is that child rearing practices do influence stress proneness. There are two variables here. One is child rearing practices, the other one is stress proneness in completing school projects. Okay, the hypothesis says that child rearing practices influences stress proneness. Okay, on basis of data available, the null hypothesis is rejected at 0.01 level of significance. What decision may be warranted in respect of the research hypothesis? When the null hypothesis is rejected, we accept the research hypothesis. We'll look at the options here. Option A, research hypothesis will also be rejected. Research hypothesis will be accepted. C, both research and null hypothesis will be rejected. D, no decision can be taken. No. Option B is the right answer. When the null hypothesis is rejected, research hypothesis is accepted. Second question, which of the following statistical technique will be appropriate for data analysis when the observations are available in form of frequencies? Okay. When it is available in form of frequencies, it is chi-square test. We'll look at the options here. A, parametric t-test. B, non-parametric t-test. C, non-parametric chi-square test. 4, parametric correlated t-test. C is the right option. When it is available in frequencies, we go for chi-square test and see the fit between expected frequencies and observed frequencies. At the stage of data analysis, in which quantitative techniques have been used by researcher, the evidence warrants the rejection of null hypothesis. Which of the following decisions of the researcher will be deemed appropriate? Okay, at the stage of data analysis, the evidence suggests that the null hypothesis be rejected. In that case, what the researcher will decide? Similar to first question. Options, rejecting the null hypothesis and also the substantive research hypothesis. Rejecting null hypothesis and accepting the substantive research hypothesis. Rejecting null hypothesis without taking any decision on the substantive research hypothesis. Accepting the null hypothesis and rejecting the substantive research hypothesis. Okay, the data analysis suggests that the null hypothesis be rejected. So once that is rejected, we accept the substantive research hypothesis. Next question. Which of the statements is true in the context of testing a hypothesis? A, it is the alternative, only the alternative hypothesis that can be tested. B, it is only the null hypothesis. C, both alternative and null hypothesis can be tested. And D, both alternative and null hypothesis cannot be tested. Okay, when it comes to testing of hypothesis, it is only the null hypothesis that can be tested. So B is the right option. Last question. Male and female students perform equally well in a numerical aptitude test. This statement indicates, okay, the statement says that they perform equally well. So there is no difference between men and women. No difference. The term no difference equals to null hypothesis. So this statement is a null hypothesis. Second option is the right answer for this question. With that, we come to an end of today's revision. Please do like and share this video and subscribe to Druv Online Academy. Thank you.